Hello everyone. Today we are going to see the project name called AI-based cosmetic recommendations based on the skin conditions. So in our project, skin disease diagnosis is done by dermatologists through visual examinations or laboratory tests. Although these methods are accurate, they are costly, time-consuming, and require expert availability. In many rural or remote areas, access to dermatologists is limited, which leads to delayed diagnosis and improper skincare practices. So, with the advancement of artificial intelligence and deep learning, image-based skin analysis has become possible. Deep learning models, especially convolutional neural network, can automatically learn the patterns such as a texture, color, and shape from skin images. However, training large models require huge dataset and high computational power. To overcome this challenge, our project uses transfer learning mobile net B2 model, which is lightweight, fast, and efficient. The system classifies skin images into five factors. In addition to disease detection, our system also provides personalized cosmetic recommendations, including skincare routines, suitable ingredients, and product suggestions. The model is deployed using both a dedicated desktop application and a Flask web application with the user authentication, making it practical, accessible, and user friendly. So this is our block diagram. So in our block diagram, the process starts with the user interface, which can be either a ticketed desktop application or a Flask-based web application. So here, the user uploads a skin image after login in the web version. So next is the image acquisition block where the uploaded skin image is received and validated. Only a validated formats are accepted to ensure reliable processing. So the image then moves to the pre-processing block. In this stage, the image is resized to 224 into 224 pixels and then normalized and pre-processed according to the MobileNet V2 requirements. So after pre-processing, the image is passed to the deep learning model MobileNet V2. This lightweight CNN extract important features such as a skin texture, color, and lesson patterns. Transfer learning allows the model to work efficiently even with a limited dataset. So after that, the skin disease classification block. So here it classifies the image into one of the five skin condition categories. A confidence score is also generated to show how reliable the prediction is. Based on the predicted condition, the cosmetic recommendation model provides personalized skincare routines and recommended ingredients and the product suggestions. So finally, the output display shows the predicted skin disease confidence level, and cosmetic recommendations clearly to the user through the web application. So this is our training code. First, we are importing all the necessary libraries, and then we are setting the image size, batch size, epoch. Here we have trained our model with these two stages. In the first stage, we took the epoch of 25. In the second stage, we took the epoch of 15, and number of classes we are here defining five classes. So we are going to predict five classes. So learning rate also we are defining here. Then we are loading our pre-trained mobile net weight path. So here we are augmenting our data set. So with the data set which we have, with that we are using augmentation for a better learning and better accuracy. After that, we are splitting the dataset for a training and validation purpose. So here we are loading our mobile net path. The first stage, we are training our model with the epoch of 25. We are using categorical chromatography. If we use a multiple class means then we will use the categorical chromatography or else we will use the binary classifications. So at last our model will be saved in the name of best underscore mobile net underscore skin dot h5. So once the stage one training completed means then it will be forwarded to the stage two. So in the stage two, we will train with the 15 epochs. So at last, in the final classification, it will give the report along with the confusion matrix and the validation accuracy and along with the validation loss of stage one and stage two. So this is our tick inter GUI test code. So here we are first importing all these necessary libraries. After we are loading the model which we had trained in the training code, setting the image size, here we are defining our five classes names. So here we are defining the cosmetic recommendations. So if it is a normal means what are routine ingredients and what products should have to suggest. So those things here we are defining for the five classes. So if the in the predicted image, first it will check the image size. If the image size is correct or then only it will accept, or else it will be pre-process that image. Once after the pre-processing, then only it will be sent to our model. So this is the ticket UI. So there should be one button upload image. If you upload the image means then it will be pre-processed and then resized. Then it will give to our model. So our model will predict and it will tell the recommended routine, the ingredients and along with the suggested products. So this is our app code like web application code. So here we are using Flask for connecting backend to frontend. First we are importing all the necessary libraries and then we are setting up the Flask. After we are creating a database for user registration purpose. So our database name is users.db. So for prediction, for analysis, everything we need a login. So once if you log in means then only we can predict. So in the database, it should contain the ID, name, email, password. So here we are loading our model. So here also we are setting the image size and we are defining the classes. So this is for a same recommendation database. So this is for a predicted skin. If you upload the image means then it will be pre-processed here. And if in the web page it will show along with the confidence. So these are all our routers. So we have an index route, about route, register, login and logout and analysis predict route. So in the register route, we need to provide a name, email, password. Once if you provide means those records will be stored in our database. So once if you try to log in means then if you provide email password means then it will be looked to our database. If it is already registered means then it will allow us to predict or else it will throw invalid login details. So for a prediction, we need a login. So once after if you log in means then it will ask to upload an image. So if you upload the image means then it will be pre-processed and that pre-processed image will be given to our model. So our model will predict and it will display along with the confidence score and the recommendations. So once if you run the Python space app.py means then it will give a link. So we need to follow that link. This is our web page. So AI power skin analysis and cosmetic recommendation. This is our home page. So here we got a 87% of accuracy and we analyze a 5+ skin cases. So analysis time is zero point 0.2 seconds. So directly you can get diagnosis from here also like you can predict from here also if you logged in means. So first it will ask us to register. For a registration, it will ask the name, email and password. Once if you created the profile means then it will redirect our login page. So we need to provide the same email and password which we had used for a registration. So once if you log in means then it will be redirected to our prediction page. So this is our prediction. So we need to upload the image. So this is our data set. We have a five classes. So first I'm going to check with the normal data set. So we need to once if you choose the image means then we need to click the analyze skin condition button. So it's predicting normal with the confidence of 96%. Recommend the protein and key ingredients and suggested products. Now we'll check with the another image. Now I will choose the any of disease like wars, molluscum, giving so it's predicted was only with the confidence of 94%. And also it recommending the routine, key ingredient and the suggested products. We'll upload with the another image and check. Eczema, I'm uploading. So it's predicted eczema, 96% of confidence and the personalized recommendations. So here we have a back to home button also. So this is our about page. So about of our project, average processing time and skin conditions. So if you click the back to home page, then it will redirect to our home page. So we have analysis. So these are all the model performance graphs. So in the training time, we got some graphs, how much it learned and confusion matrix. So those graphs will be presented in this analysis. So we have a logout button also. If you log out means then it will ask us to log in. If you didn't log in means you need to register from the first. So we have already logged in. So directly you can get the prediction by get diagnosis also. And then if you click the learn more means then it will be redirect our about page. So